Hey everybody. So this is a super interesting research paper that caught my eye very specifically because I'm not going to say that like at least one of these authors have come across my work definitively, but I would be like there's a lot of coincidences. It's how I would frame that overall, right? And then like that's good overall. And this research paper is called Large Language Models as Innovators, a framework to leverage latent space exploration for novelty discovery. And then this research paper deals very specifically with LLM models and the latent space, whereas like all of my research, like a majority of my research is around like swarm algorithms and latent space exploration in this manner. But let's dive into this, right? So this is their framework. And then so essentially how this framework breaks down is you take two ideas, right? Idea A and idea B, and then you vectorize them. So vectorize idea A, vectorize idea B. You combine those two vectors via ideation, and then essentially you get a result, like a probabilistic result that comes out of that, and then that blended result. And you can utilize different reward mechanisms for that blending process, and you can blend over multiple generations, right? I'll show you an example. We blend like 25 generations out, right? It's possible and then that's essentially just what this process is overall. And then what this process operates off of is the latent space of the models, right? And then the latent space, this process essentially operates off of the latent space being almost like a physical object, it's being an enclosed space with physics inside of that space, right? So it is a physics-based object in that particular sense, like 1,000,000%. And then, diving deeper into this, so their method is pure LLM model, and I'll showcase that to you. But I want to showcase. I've been working on and hypothesizing around this particular method now for like a couple of years, basically, right? I equate it out in different ways. So to me, the latent space is essentially like a magic box. And then so you can drop a problem into the magic box. And then so the problem would be a vector, right? So we drop the problem vector into the magic box. And then we'll call them solution variables. And then solution variables would be things that we think would lead towards a solution, but we're not 1,000,000% sure. But we want to create connections between the problem vector and the solution variables. And then essentially we operate and we control the box in that manner, right? And then we drop an agent in there, and then the agent, it should be able to figure out. And then if there's enough solution variables that connect to the problem vector, the agent should be able to figure out what the solution is within the problem space, like within that latent space of the problem. And then so I've gone over kind of like a few different models and built them out like within this right here overall. I'll just highlight them, right? So you've got this swarm neural network image diffusion V2, which is 100% related to this. A swarm poker agent, 100%. API call diffusion with swarm neural networks. 2.5, 2.0, 5B swarm function caller. This one, the SNN image generator, API call swarm caller. So all essentially 7 of these are all related to this concept, right? And then I also have this notebook here, which I made here we go, a few months ago, or back in February is when I made this particular one. Essentially what this notebook is so this is the target image, right? So this is the original image. And then we get our end output here. So this end output isn't actually an image. This is swarm algorithms recreating this image within the latent space, right? So I drop the image as the problem vector, and then I give it enough solution variables in order to recreate the image of the cat. And then we can do the same thing with sentences and text here. So here we've got just a noisy sentence that we deconstruct. And then I've got it, I start training the model on this instance and then through here. But so there's a lot of different things that you can do with this latent space, right? This is solution space. It doesn't have, I'm showing out, it can be images, text, video, whatever you would want to put into latent space, right? It would be significant amount of compute to put video into it. But then, so let's break this concept down into an applicable code specifically for this paper. So this paper breaks down and it utilizes, it utilizes LLM models in this instance, and it talks about LLM models for the latent space. So we'll focus on that, although I do want to point out one thing here that we will focus on as well within this, because it's majority of my research within this. But so looking ahead, several avenues for future research emerge, developing more sophisticated latent space exploration strategies, such as swarm-based optimization algorithms, will be crucial to increase the efficiency of idea generation and improve flexibility. They call it out right there very specifically, right? So let's go ahead and go over here. And then we've got our latent space ideation with advanced swarm queen optimization. So this Google Colab notebook implements a powerful latent space ideation framework that combines the strengths of modern language models and swarm intelligence. It allows users to generate novel, high-quality ideas by navigating and manipulating embedding spaces using a custom-built swarm queen optimization mechanism. So what this notebook does, it encodes ideas into embeddings utilizing sentence transformers, explores the latent space via a swarm of intelligent agents guided by a central swarm queen, interpolates and it mutates the concepts in the vector space to spark new innovations, and then it decodes ideas back to human language, scores and ranks those ideas, and then so real world use cases of this, like so the first example of this is, and first use cases, we combine like a smart water bottle that tracks hydration with a solar powered portable charger to discover a product that is a solar powered smart water bottle that tracks hydration and purifies water utilizing sunlight. And then so I'll demonstrate and showcase that here for you, right? So here's all of the code. I vectorized the two concepts, and then I give it like a bunch of potential solutions in this instance, right? And then so in this first instance, I'm giving it a bunch of potential solutions rather than giving it like an LLM model or anything like that in order to do anything, further with that. And then so again, we have our ideas, idea number one and idea number two. Idea number one being a smart water bottle that tracks hydration and reminds you to drink. And then idea number two being a portable solar charger for electronic devices. And then it essentially searches through the latent space to come up with a new product idea, which is a water bottle that generates its own power from the sun to run smart features, like tracking intake and powering a purification system. And then so this idea was identified because its conceptual vector was closest to the average of the smart water bottle and the solar charge vectors. And then so that's very specifically and simplistically how it was able to come up with the solution in that particular instance. And then so as mentioned and as previewed, they mentioned that the best way to do this and to take this forward would probably be to do a solution like combining LLM models with swarm algorithms in this particular instance, right? And then so that's what we do in this particular instance. In this second notebook here is we combine it with my swarm queen optimization, and then I utilize a Gemma 2B, a Gemma 1B model in this instance. I think Gemma 2 1B, Gemma 2B in this instance to train the model and to be the LM model in this instance. And then so what we do is we create and we score 5 ideas, right? And then so the swarm, so we have our 5 ideas, and then we create them into vectors, code them into vectors, and then ideate based off of those vectors. And then so like the concepts get kind of crazy because they get into like a kind of stories, and then the model is creating these on its own, right? So it creates concepts, and I also cut it off really quickly as like 70 tokens. So it's like you have a concept like the ruins of an ancient civilization stand as a testament to a bygone era. They're intricate, and then it cuts off the tokens, and then creates a new idea based off of all of these previous ideas, right? And then so the new idea in this instance would be paints the landscape in a symphony of hues from vibrant yellows and oranges to deep greens and blues. Animals in harmony with nature adorn the flora with dazzling feathers, colorful scales, and intricate patterns. And then it kind of iterates from here, right? We get multiple iterations of it going through. So we get iteration 2. And then so from there, we get more ideas, right? So at birth, children are given a problem-solving blueprint. And then as you emerge from the castle's ruins, you hear the quiet murmur of a stream winding through the forest undergrowth, etc. So it starts majorly and significantly evolving from there, right? And then that's kind of the whole entire concept of what this does, right? It explores the latent space, explores the problem vectors within the latent space to create unique and creative solutions within it overall. And that's kind of what this overall framework does, what we're looking at here, and what this research paper kind of proves out. So it's interesting to me again overall because this is a concept that I've been talking about for a long time and for a long while now. I just talk about it very specifically as it relates to swarm algorithms because I think that swarm algorithms are the best mechanism in order to explore this latent space, but you can absolutely combine that with LLM models as I've demonstrated here. And then so I'll leave a link to all of this, both the Colab notebook as well as the research paper here. And if you like this type of content, please like and subscribe. Thank you much.